Hello, I'm Akis, a developer here at FlyRank. In the previous assignment, I built the REST API for managing tasks with full CRUD functionality. For this assignment, I continued working on the same project and added an AI-powered trivia quiz feature. The new endpoint is post/quiz. It accepts information such as topic, difficulty, and number of questions and uses Gemini to generate a trivia quiz. The main focus was not just making an AI request, but integrating into the existing backend in a way that keeps the API key secure, separates the AI provider from the application, validates the AI response, and tracks usage and estimated cost. I started from the project I created in the previous assignment. The existing task API is still part of the application. I did not create a separate project for the trivia feature. The CRUD endpoints for tasks continue to work, and I added the quiz functionality alongside them. This demonstrates how we can take an existing backend and incrementally add a new feature instead of rebuilding the application from scratch. Before I could make an AI request from a backend, I need the Gemini API key. I went to Google AI Studio and signed in with my Google account. From the API key section, I can create or view Gemini API keys. Google AI Studio can automatically create a project and API key for new users. If I need another key, I can use the Create API Key option and associate it with a new project. After creating the key, I copied it into my local environment. I did not push the key directly into my source code. Instead, I added it to my env file as an environmental variable. For example, I use something like Gemini API key in my environment configuration. The important part is that the actual key is never committed to GitHub. So it's basically gitignore. Google also recommends using environment variables for securely configuring the key in applications. I also made sure the env is included in gitignore. Once I had the key, I connected my existing backend to Gemini. The backend reads the API key from the environment and uses the Gemini SDK to make the request. At this point, I tested a simple AI request to make sure the backend could communicate successfully with Gemini before building the actual trivia functionality. This gave me the basic flow. I can try it out right now. My API receives a request, the backend calls Gemini, and Gemini returns a response to my backend. After establishing the connection to Gemini, I added the new post/quiz endpoint. The client sends information about the quiz it wants to generate. In my implementation, this includes the topic, difficulty, and number of questions. For example, I can ask for 5 medium difficulty JavaScript questions. The backend validates this request before sending it to Gemini. This follows the same principle from the previous assignment. The server should validate incoming data instead of assuming the client sent something valid. Once the request is valid, it is passed to the AI service to generate the quiz. One of the most important parts of this assignment was dealing with the AI response. An AI model normally generates text, but my application needs predictable data. I therefore defined the structure that I expect for a trivia quiz. Each question contains the question itself, a list of options, and the correct answer. I then instruct Gemini to return the quiz in JSON format. But simply receiving JSON is not enough. JSON can be syntactically valid while still having their own structure. So after receiving the response, I parsed it and validated it against my schema. This allows my backend to catch problems such as missing fields, an incorrect number of questions, or questions that don't contain the expected options. Only after the response passes validation do I return it to the client. I also separated the application from Gemini itself. The quiz endpoint does not need to know the details of how Gemini works. Instead, the application communicates with an AI service or provider interface, and that layer handles the Gemini-specific implementation. This gives me one SIM between my application and the AI provider. If I want to replace Gemini with another provider in the future, the rest of the quiz functionality would not need to know about that change. This is useful because it prevents provider-specific code from spreading throughout the application. The final production-oriented feature I added was usage and cost tracking. For each AI call, I log information such as the provider, model, input tokens, output tokens, total tokens, and the estimated cost of the request. This gives me visibility into what happens when my application uses the AI provider. Even though this is a small trivial application, tracking token usage is important because AI calls can become a significant operational cost as the number of users and requests increases. I can therefore look at a single request and understand how many tokens were used and approximately how much that request cost. To summarize, the backend first validates the request, it then calls Gemini through the AI service, Gemini generates the trivia questions, and my backend parses and validates the response and gets the expected schema. Once the response passes validation, the structured quiz is returned to the client. At the same time, the logs show the token usage and estimated cost for the AI request. The main goal of this assignment was to take the REST API from the previous assignment and extend it with a real-powered feature. I learned that integrating an AI API is more than simply sending a prompt and displaying the response. The backend needs to protect the API key, isolate the AI provider, validate the model's output, and keep track of AI usage and cost. The result is the same task API from the previous assignment, now extended with a production-style AI-powered trivia quiz endpoint. Thank you for your time, and please let us know of any questions.